So the product of vectors, we have seen the definition of a scalar product and it's a geometrical interpretation. And next part is the vector product of two vectors. Let me share my screen. Let us discuss the vector product and the basic difference, between the scalar and vector product. In the scalar product, the result is a scalar, and in the vector product, the result is a vector. When it is a scalar, then there is no problem in the direction of it, because the scalar itself will have only magnitude but no direction. But when you see the vector product or cross product, it is named as vector product, but because the result is a vector. The result is a vector. So if it is a vector, if the cross product or the vector product is a vector, then what should be its direction? That's very important. How its direction will be. Like if you take, are you with me, both of you, please? Yes or no? Pranit, A bar cross of B bar is equal to modulus of A bar into modulus of B bar into sine theta into n cap you will have for the vector product, where n cap is a unit vector in the direction of A bar cross B bar.
Okay, sir.
N cap is a unit vector in the direction of A bar cross B bar. To make A bar cross B bar a unit vector, you have to divide A bar cross B bar with modulus of A bar cross B bar. Now, what is the basic difference between the scalar product and vector product is that in the vector product, you will have the direction along with magnitude, whereas in the scalar product, you will have only magnitude, but no direction. Now, it is very important that to understand the direction of A bar cross B bar, because further in all the problems, you must have the better understanding about this. You must have the better understanding about this. Just if you have two vectors like this, one is A bar, other one is B bar, then it's perpendicular. Its perpendicular will be the resultant A bar cross B bar will always be perpendicular. Will always be perpendicular. Very, very important, please. Very, very important what I'm saying. See, it will be like this. Perpendicular to the plane containing A bar and
A bar. Yes, sir.
And you must have this basic knowledge about the cross product. Frequently used.
Okay,
Frequently used. If you take the plane containing A bar and B bar like this. Let me change it, just a moment. I'll show you more clearly. This is a plane containing the two vectors, A bar and B bar. Then I want to show you the direction of the vector, which is perpendicular to both A bar and B bar. That means it will be like this. That means it will be in the direction which is perpendicular to the plane containing A bar and B bar. Now, you please confirm whether you know this or not, because it is a very, very basic point you must know. It is a very, very basic point you must know to solve all the problems. This is A bar cross B bar. What is the angle between these two is always 90 degrees. This is what you have to understand. Okay. Now, what is the geometrical meaning or geometrical interpretation of A bar cross B bar? Geometrical interpretation of A bar cross B bar is like this. If you take a parallelogram whose adjacent sides are A bar and B bar, if you take a parallelogram whose adjacent sides are A bar and B bar, and if you find out the cross product, A bar cross B bar, and its magnitude of the cross product gives you the area of the parallelogram. So the geometrical meaning of vector product is nothing but modulus of A bar cross B bar is equal to area of parallelogram. Area of parallelogram whose adjacent sides are A bar and B bar. This is what you have to understand. This is the geometrical meaning of it. I'm not going to derive it because you can derive it, but it's not that important. Just understand this. So geometrical meaning of scalar product we have already taken. It is orthogonal projection of A bar and B bar. It is orthogonal projection of A bar and B bar into mod B bar. So like that, the geometrical meaning of cross product is area of the parallelogram. Okay. It's clear, please. Both of you respond.
Yes, sir.
Yes, sir.
So now let us check the definition here given. Let A bar and B bar be non-zero, non-parallel vectors. Why he is saying it as non-zero, non-parallel vectors? If any vector becomes a 0 bar, then the product becomes 0. That is why he is saying to define it. Non-parallel means parallel. If it is parallel, theta becomes 0. That's what the definition I gave you here. A bar cross B bar is equal to mod A bar into mod B bar into sine theta into n cap, where n cap is a unit vector in the direction of A bar cross B bar, where theta is the angle between the two vectors. Theta is the angle between the two vectors A bar and B bar. And very importantly, you have to understand that this forms a right-handed system. First of all, what is the meaning of right-handed system? Do any one of you please tell me what is the meaning of right-handed system and left-handed system in three-dimensional geometry? Kaushik and Trinit.
Sure.
My question to you: what is the meaning of right-handed system and obviously left-handed system? Any one of you, no problem. If you know, you say, otherwise I'll explain, but I want to know whether you
The right-handed means
remember
nothing.
this or not. Yeah, tell me.
Nothing but both A and B forming right angle triangle, whose direction cosines are equal to A and B, like 90 degrees. Theta should be equal to 90 degrees. Sir.
Huh. And that Kaushik,
Sir.
I asked a question here. Right-handed system. Just I kept in the box also. Just see that. What is a right-handed system?
Sir,
Do you see the screen here now?
No, sir.
No, not. I'm not sharing the screen. Do you see the image there?
Yes, sir.
Pranit. Pranit Babu.
Sir,
See, do you see the hand there? Hand with 3 fingers.
yes, sir, yeah.
That is my hand only. Okay. See, this forms a right-handed system.
Yes, sir.
From red to blue. This is
A and B.
sky blue. Sky blue I'm talking about. Red to
Okay.
sky blue. If you move to thick blue, that is arrow marks I'm talking about. Red arrow, sky blue arrow, and thick blue arrow. If this is rotated, red to blue, red to sky blue to thick blue, if it is rotated, this is called right-handed system. Remember that.
Okay, sir.
If you reverse that hand,
Left-handed
then
system.
what happens? That
Blue will come. Yes.
blue will come down. It will see down. It
Yes,
will
sir.
see the floor. Then in that
Red will see the opposite side, and the sky blue will see another opposite side.
that's what it is.
Upward
That is
side.
called left-handed system.
Okay, sir.
I'll give you a simple understanding about that. Kaushik, are you there?
Yes,
I'll
sir.
give you a simple understanding about that. You know, screwing and unscrewing.
Yes, sir.
Screwing means if you take a screw, if you
Bolt to a wall.
and if you are screwing it, that is you are sending that screw inside a wood, let me say. Then
Yes, sir.
what if that inside wood, if to send that screwing is nothing but left-handed system, and unscrewing is right-handed system. Simple.
Mhm.
Unscrewing means what happens? That
You're removing the screw out of the
come
wood.
onto your face.
Yes, sir.
Unscrewing, the screw come onto your face. Okay. When unscrewing, you will make use of your thumb and this forefinger. Thumb and forefinger. Okay. Let me show my video once. Just a moment, please. Kaushik Babu, are you there?
Sir, no, sir.
ఇప్పుడు ఇలా ఉంది. ఒక స్క్రూని మనం అన్స్క్రూ చేస్తున్నాం. అన్స్క్రూ చేసినప్పుడు ఇలా తిప్పుతాం.
ఇట్లా తిప్పుతున్నాం, అవును.
ఇలా తిప్పినప్పుడు ఇది ఏ బార్, ఇది బి బార్ అన్నమాట. ఇలా తిప్పినప్పుడు స్క్రూ పైకి వస్తుంది ఇలా. దీన్ని మనం ఏమంటాం అంటే రైట్ హ్యాండెడ్ సిస్టమ్ అంటాం. అంటే అన్స్క్రూయింగ్ లో వచ్చే వెక్టర్ డైరెక్షన్ ఉంది కదా, ఇది ఏ బార్ ఇది బి బార్ అయినప్పుడు ఏ బార్ బి బార్ ను ఇలా తిప్పినప్పుడు ఇది ఒక ప్లేన్ కింద ఫామ్ అవుతుంది.
అవును సార్.
ఈ ప్లేన్ మీద ఫామ్ అయినప్పుడు ఈ వెక్టర్ ఎలా వస్తుంది? అప్పుడు పైకి వస్తుంది, ఇలా వస్తుంది.
అవును సార్.
కాబట్టి ఏ బార్ బి బార్ అండ్ సి బార్ ఫార్మ్స్ ఏ రైట్ హ్యాండెడ్ సిస్టమ్. ఏది అంటే బెటర్ ఎగ్జాంపుల్ అన్స్క్రూయింగ్. అన్స్క్రూయింగ్ ఫర్ ఎగ్జాంపుల్ ఇలా తిప్పుతున్నాం అంటే స్క్రూ చేస్తున్నాం. స్క్రూయింగ్ ఇలా
ఏ బార్ కిందకి వస్తుంది, బి బార్ పైకి.
అంతే, సింపుల్. కిందకి ఏ బార్ క్రాస్ బి బార్ కిందకి వస్తుందిరా. దట్ ఈస్ కాల్డ్
స్క్రూయింగ్. లెఫ్ట్ హ్యాండెడ్ సిస్టమ్ స్క్రూయింగ్.
ఇన్ ద రికార్డింగ్ ఐ గాట్ తెలుగు.
ఎడిటింగ్ చేయండి సార్ పైకి.
That's not that easy. Okay, so unscrewing is right-handed system and screwing is left-handed
system.
Understand that? I hope you understand.
Understood.
Then if you are given 3 vectors A bar, B bar, C bar, for example.
Sir.
Hey, Kaushik Babu.
Sir.
Are you listening to me?
Okay.
English.
So if you are given 3 vectors, how do you understand that those 3 vectors are forming a left-handed system or right-handed system?
For right-handed system, A and B should face the upward side, and for left-handed system, downwards.
That's okay. But algebraically, how do you prove it? That's what I'm saying. Very simple, very simple. I'll tell you like this. You have to find out box ABC, because box ABC so
Okay.
far I have not given you, but I'll
Yeah,
tell you
sir.
simply, very simple like this.
Okay, sir.
Box ABC means scalar triple product. Scalar triple product means box ABC is equal to A bar cross B bar dot C bar. A bar cross B bar dot C bar. A bar cross B bar, this is A bar, this is A bar, this is B bar. A bar cross B bar gives you C bar, upward direction. C bar is in the upward direction. Then A cross B dot C is positive, remember. A cross B dot C is positive. If it is screwing now, A cross B dot C will be negative in the opposite direction. So remember, when you find out the cross product, if you have another vector, third vector C bar, if you are finding the scalar triple product, if the scalar is negative, scalar triple product, if the scalar triple product is negative, you have to understand that it is a left-handed system. If the scalar triple product is positive, you have to understand that it is a right-handed system. Very simple. I hope you understand. Finding the triple product means it is nothing but the determinant, nothing other than that. It is nothing but the determinant. Better, what I do, I'll take an example and I'll explain so that you will better understand. Okay. Just see that I'm sharing my screen again. Just a moment. I'll explain it like this. I'll explain it like this. Comma. You tell me any vector of your choice, Pranit. We are three here. We will take three vectors. You tell me first one, and I will take second one from Kaushik. Third one I will write. Come on, tell me of your choice. Pranit, Babu, A bar, any vector of your choice.
3 plus 4.
No, tell me that in IJK.
It's okay, sir. 3i cap plus 4j cap.
Okay.
What did you write? Okay. Minus 6k cap.
Okay. You're taking big numbers.
And
And B bar, let us take from
sir, ask Kaushik Babu.
Siddharth Kaushik. Please
I
tell
plus 2j plus 3k.
Come on.
I plus 2j plus 3k.
I plus 2j plus
3k.
and C bar, I'm taking it minus I plus j minus 2. Now these are three vectors. You want to understand whether these three vectors are forming a right-handed system or a left-handed system. So very simple thing is that you have to find out box ABC for this. Box ABC detailed explanation I'll give you after the cross product. But because the situation has come, I'm just taking it up. Now, box ABC is very simple that you have to understand it is 3, 4, minus 6 and 1, 2, 3 minus 1, 1, minus 2. I'm not going to solve this determinant. You both please solve and tell me the value, please. Yes.
Sure, sir.
You. Tell me the value of the determinant there.
Yes, sir.
Kaushik Babu, you're taking more time to solve this determinant. -4, -7 into 3, -21.
-21 plus 4
-3 plus 2, -4. And 1 plus 2, 3, 3 minus 18. You've got negative.
-12, sir. -12.
Yeah. Minus?
-29, sir.
Minus?
No.
Minus,
20.
-43, I think. Just check it out. -4, -2, -7, -21, and it is -3 plus 2, -1, -4, correct. And it is 1 plus 2, 3, -18, correct. But I need whether it is negative or positive.
-43, sir.
It is negative.
Negative.
Therefore, A bar, comma, B bar, comma, C bar form RHS.
Negative.
Sorry, LHS. Why LHS?
RHS doesn't form, sir.
Why LHS?
Negative, sir.
Negative, you got. If it is
It
positive,
won't pass, sir. Like,
if it is positive, you can say that.
it will form RHS also.
RHS. Okay, now this is what you have to understand. This is what you have to understand. This is one vector, this is another vector. And what we need is A bar cross B bar. A bar cross B bar is always perpendicular to both the vectors. If this is like this, let me say, then you will find one more vector also in this direction. So what makes the difference? What makes the difference? You have to understand, if this is A bar, if this is B bar, and this is C bar, this will be calculated, this will be taken in this direction, anti-clockwise direction. This C bar, let me say this as A cross B. Then this will be what? Any one of you, please? Any one of you? It is in the upward direction, it is in the downward direction. What makes the difference? It will be just reversed. What's it? That is A cross B, and this is B cross A.
B cross C.
B cross A. That means A cross B forms a right-handed system, and in this case,
B cross A forms left-handed.
left-hand system. And it is there. It is C bar, and here it is minus C bar.
Minus C, yes.
So whenever Kaushik, whenever
Babu.
Sir,
whenever you have you will have a question like this, please, both of you. Very important, very important. Frequently asked question is this: find a unit vector perpendicular to both A bar I minus j plus 2k and B bar 3i minus j plus 2k. Brilliant. Very, very important. This one. This one is very, very
Okay,
important.
sir.
Please. Unit vector perpendicular to both. Unit vector perpendicular to both. Whenever you are given two vectors, you need a vector which is perpendicular to both. It's ultimate that you have to find out the cross product.
Okay, sir.
Kaushik is there.
Kaushik Babu.
sir, what is this, sir? How many times will ask, sir? I'm here only.
Because I love your name. That is why I'm calling you many times.
I have a disturbance, sir. That's why I'm switching off the microphone, sir.
Really?
Yes, sir.
You are so great. You are so great. Right. You tell me now, what is unit vector perpendicular to both? Unit vector perpendicular to both A bar and B bar. Any one of you, please?
Sir,
I'm asking you the question here.
unit vector
perpendicular to both A bar and B bar. First of all, in the initial explanation itself, I taught you that it is A bar cross B bar is a vector which is perpendicular to both A bar and B bar. Did I explain it or not, Praneeth and Kaushik? Then when you need a vector which is perpendicular to two vectors, it is obvious, it is inevitable that you have to find out the cross product. After finding the cross product, if you want to make it a unit vector, divide that particular vector with its magnitude, and it is plus or minus. Now my question to you, when it will be plus and when it will be minus? Any one of you, please. Any one of you. When it is plus, when it is minus, it will be plus when it is taken in the right-handed system. It will be minus when it is taken in the left-handed system. Plus will be above the plane and minus will be below the plane containing A bar and B bar. And how to find out A bar cross B bar, please? Any one of you? Working rule for A bar cross B bar. It is again the determinant, please. It is again the determinant. Come on, tell me that. Now, this is the determinant I'm writing here. Very simple, very simple. First row will be I bar, J bar, K bar. And second row will be 1, minus 1, 2. Third row will be 3, minus 1, 2. Are you there, everyone, please?
Yes, sir. Yes, sir.
Yes, sir.
So I repeat this. I did not prove it, but I'm writing this directly. Finding the cross product is nothing but finding the determinant of this. Okay. Now this will be modulus of A bar cross B bar, means you have to write this. I'm writing this because you understand this directly. What is modulus of A bar cross B bar? Determinant of this. This is minus 2 plus 2. Minus 2 plus 2. 0. 0 I bar. It is done. 6 minus 2. 4 J bar. And it is minus 1 plus 3 plus 2 K bar. What is that missing here? Plus or minus is missing. Why should we write plus or minus? Kaushik and Praneeth.
Sir,
Why should we write plus or minus?
So it could be above the
it will be above the line, below the line, or on the line.
No, above the plane.
above the plane or below the plane, sir. So
Correct. Very good.
Okay, sir. Okay, sir.
Which is to be taken for above the plane? Plus.
Positive.
Positive. And which is to be taken for below the
Negative.
negative. That's what it is. So plus or minus 4J plus 2K whole divided by
4 square.
4 square plus 2 square is how much? Root 20.
Root 20, sir.
Root 20 is 4 into 5, 2 root 5.
4j plus 2k by 2 root 5, plus or minus.
Yeah, you're right. Plus or minus 2j plus k upon root 5. Okay? That's it, please. That's it. So, very important point, what I'd like to insist upon. In the deleted syllabus, you have that triple product. Triple product, in fact, is deleted. That means you must, they must give the questions up to vector product only. That is double product. Triple product is deleted. And hence, you must be thorough up to this at least. That means in the basics, particularly, if you are thorough in the basics of this, then the questions definitely they'll have to form and frame up to this syllabus only. So that's the reason why I'm insisting upon this one. Unit vector perpendicular to both means it is obvious that you have to find out the cross product. Okay. Erasing this. Now coming to the next point.
Okay, sir.
That's what I explained already. Geometrical interpretation of a vector product. Geometrical interpretation of vector product means its modulus is nothing but vector area of the parallelogram. Just see that. What's it? Vector area of the parallelogram OACB. That is nothing but the geometrical meaning of it. Thus, A bar cross B bar is a vector whose magnitude is equal to area of the parallelogram having A bar and B bar as its adjacent sides, and whose direction n cap is perpendicular to the plane of A bar and B bar, such that A bar, B bar, n cap form a right-handed system. This is what you have to understand. A cross B represents the vector area of the parallelogram having adjacent sides along A bar and B bar. This is what you have to understand. And geometrical application of it, even finding the area of the parallelogram, you will have to make use of this. Area of the parallelogram is equal to modulus of A bar cross B bar. What is A bar and B bar? They are the adjacent sides of the parallelogram. And even it can be taken as area of delta OAB is half of area of parallelogram OACB. Because when you take a parallelogram, half of it forms a triangle. Half of it forms a triangle. Now let us see the properties of vector product. Very, very important is that in the scalar product is always commutative. Scalar product is always commutative. A bar dot B bar is equal to B bar dot A bar is possible there. But vector product is not commutative because it differs in the direction. It differs in the direction, and hence we have to write a minus for this to equate them. Difference between A cross B and B cross A will be, magnitudes will be same, but the directions will be exactly opposite to each other. Directions will be exactly opposite to each other. This is what you have to understand. So rest all, it distributive law, it follows, and right distributive law, left distributive law, this all it follows. And A bar cross of B bar minus C bar, you should not deviate the position of A bar here. If it is on left hand side, you must keep it on left hand side only, and you should not interchange as you like, because A bar cross B bar is not equal to B bar cross A bar. That's what he has given here. You can see A bar cross B bar is equal to minus B bar cross A bar. If it is a scalar product, no problem at all. A dot B, B dot A are one and the same. These are some properties you have to understand.
Understand.
Okay, next. Next, please. We are seeing the properties here. Now, this is important, please. This is important. Just listen to this carefully. Listen, please. Now, Praneeth, do you tell me, please, what is A bar cross B bar? Mod A bar? Mod B bar?
Sir.
Sin theta?
Sir, it's lagging.
N cap. Do you see the screen now?
Now it's visible. Now, just now.
Yeah. Kaushik?
Sir.
A bar cross B bar is mod A bar mod B bar into sin theta into n cap. What I would like to ask you, both of you, please pay your attention.
Sir.
Pay your attention, please. If it is I bar cross I bar,
Okay, sir. A bar plus I bar.
it is
Okay.
unit vector, it is 1, and sign 0, 0. But you must be writing it as 0 bar, please.
Yes, sir. Bar should be completed.
You must have that. Because it is a vector 0.
Yes, sir. Yeah.
So J cross J, K cross K also 0. Now, I ask you I'm asking you this question now. What is I cross J? And what is J cross K? And what is K cross I?
1 bar, sir.
1 bar will not be there. 1 is a scalar, no? 1 is a
Sir,
scalar.
then 0 bar.
Yeah. Kaushik, do you answer me this?
0 bar, sir.
What is I cross J? What are
I cross
doing?
sir, I cross J, sir. That's
Yeah.
K, sir. K.
That's good. And what is J cross K?
I, sir.
What is K cross I?
J, sir.
Pranit, just listen. I am explaining that. Pranit, this is
Okay,
I.
sir.
This is I bar. Okay. This is J bar. Okay. Now this is K bar. What I'm asking you, Pranit, what I asked you, in fact,
Yes, sir.
if you are given
INJ.
INJ, correct. This is I bar given and J bar given. If you find out no I cross J, what happens? The resultant vector will be perpendicular to the plane of this, no?
Yes, sir.
Perpendicular to this plane.
Plane,
Perpendicular
yes, sir.
plane is nothing but
Case.
K bar. That's what. So I cross J is K.
K.
So it goes in a cyclic order like this. I cross J.
For J and K, I is per plane.
Ah,
So K and I, no, got it, sir.
hope you understand, no?
Yes, sir. I'm
Good. This is important thing to be understood, and based on this only, you will have the working rule for the cross product. So let me revise you the working rule for both. If A bar is A1 I bar plus A2 J bar plus A3 K bar, and B bar is B1 I bar plus B2 J bar plus B3 K bar. Now, what I mean to say here, and what I'd like to know from you, what is A bar dot B bar and what is A bar cross B bar? In working out the problems, it is only important. Come on. Any one of you, please respond. What is A dot B, please? It is also said to be inner product. Please respond. Any one of you. A bar dot B bar.
A dot B bar, sir.
Yeah.
A1 B1. Hello. Okay, sir. Right. Sir, I only A1 B1 plus A2 B2 plus A3 B.
Pranit, it is also said to be inner product because we take the inner part of I bar, inner part
Yes,
of
sir.
K bar, inner part of K bar. That is why the other name is inner product.
okay, sir.
Dot product straight away gives you that. Now, what about the cross product? Just now I gave you that. It is adjusted in the form of the determinant. It doesn't mean it is always the determinant. Cross product, what happens, I'll tell you, I'll explain you like this.
Okay.
Just what is that you have to do now? When you are finding the cross product, A bar cross B bar, this one, no? This one is to be crossed with this one. Then what happens? I cross A becomes 0.
0. J
I
cross
cross J becomes K.
K.
I cross K becomes
J.
minus J. Minus J.
Okay, minus
Because
J.
order is also to be considered like this. Kaushik, Pranit, this is
Okay.
important. Just see this one. IJK is there, for example. Then after I, J comes.
Yes, sir.
After J, K comes. After K, I comes. This is the
Cyclic order.
cyclic order. So if at all, if you follow the cyclic order I cross J, then it will be K. There's no doubt in it. But if you have J cross I, then you will get minus.
Minus K.
Minus 2. So like that, when you write the cross product like that, I cross I becomes 0 bar, I cross J becomes K bar, and
K
I
bar.
cross K becomes minus
J.
Like that, we collect all of them, and finally what the mathematician understood, that cross product is nothing but the determinant. Determinant of what? IJK, A1, A2, A3, B1, B2, B3. This is to be understood, please. This is to be understood. About the dot and cross, I think the working rule is clear for you both. Yes or no?
Yes, sir.
Pranit Babu.
Sir, understood.
Now, that's about cross product of IJK, cross product of IJK. And if you refer to previous papers, whether it is board or object, whatever, whether it is board or objective, very, very important one, based on which you find questions, previous questions. It is nothing but the Lagrange identity.
Okay. Lagrange identity.
Oh. Anyway, for your better understanding, I'm proving it. Siddharth Kaushik is there, no? Now I am proving Lagrange identity.
No,
Just
sir, not there.
not there?
No.
Yeah. He'll come. Just wait. So now what is Lagrange's identity? Praneeth, it is just the square of the cross product. Remember?
Yes, sir. Yes, sir.
It is just the square of the cross product. Now let me apply cross product formula. What is cross product formula? Mod A bar, mod B bar into sine theta, where theta is angle between A bar and B bar, into n cap, whole square. So what happens here? Mod A bar square, mod B bar square into sine square theta. That sine square theta, what I'll write it as cos square theta into unit vector modulus is 1. Unit vector modulus is 1. So 1 square will be remaining. That will be eliminated. Now, if you split it now, what is that you get? Mod A bar square, mod B bar square. Minus mod A bar into mod B bar into cos theta whole square. Are there both of you, please? This is nothing but
Yes, sir. There.
A bar square, B bar square. You can eliminate modulus there because square is there. And this is nothing but dot product. A bar dot B bar whole square. You find many previous questions only based on this concept. A bar cross B bar whole square. Of course, it is named as Lagrange's identity. You need not have to remember that name.
Okay, sir.
If you remember that name, that will be great. But anyway, you have to remember this formula.
Okay, sir. I'll remember.
Please read that once, Praneeth.
A bar cross B bar whole square is equal to A bar square B bar square minus A bar dot B bar whole square.
Kaushik. Is it
Sir.
okay? Is it
Yes,
okay?
sir.
This is Lagrange's identity, which is to be remembered. Let us move on to the next part of it. Yeah. Just now I explained you the working rule for the cross product. It is nothing but a determinant. In fact, this you will get in the cross product. So what the mathematician did, just to solve them easily, solve the cross product easily, he arranged this in the form of the determinant. That's only the difference, understand that. I hope you understand what I'm saying. This is the working rule for the cross product. Right-handed system of vectors, left-handed system of vectors. I explained it already. I need not have to explain it further. Just say this, right-handed system means it is given in the anti-clockwise direction. And left-handed system means it is given in the clockwise direction. Even in two-dimensional geometry also, the clockwise is taken negative and the
Okay, sir.
anti-clockwise is taken positive. Here,
Positive.
the direction will be anti-clockwise. It's positive, clockwise is negative. This is what I explained in the beginning. Vector normal to the plane of two given vectors. What is that I said? It is simply A cross B by modulus of A bar cross B bar. Most important one. This A cross B by mod A cross B will be a unit vector, and of course it is perpendicular to both A bar and B bar. Vineet, if I say no, something like this, C bar cross B bar, C bar cross D bar, let me say. Then if I ask you, are you there, Vineet and Kaushik?
There, sir.
There, sir. There, sir.
I'm
There, sir.
asking you a question now. If I say, what is the angle between C bar, comma, C bar cross D bar? Similarly, what is the angle between D bar, comma, C bar cross D bar? Any one of you can respond. This written in the brackets means it represents the angle.
Yes, sir. Yes.
Vector notation is vector notation in the small brackets between two vectors denotes the angle between them. Any one of you do tell me the angle between these two? If you're not answering that question means you did not understand my explanation. You did not understand the concept what I taught you.
Sir, once repeat the question.
Vineet,
Sir,
what is the question I asked? Just do it.
angle between them, sir.
That's what you tell him.
What is angle between them? Then they you don't need to.
Angle between C bar and C bar cross D bar. Angle between D bar
Sir, C bar,
and
C bar,
cross
C
D bar.
bar cross D bar. 90.
Correct.
Yes.
Praneeth, very simple thing is that C bar cross D bar is a vector product or scalar product. You tell me, Praneeth. Praneeth Babu.
Sir, vector product.
Vector product. That's good. Vector means it must have a direction, no?
Sir.
Then what is the direction of C cross D? You tell me.
Positive.
No. What should be the direction of C cross D? It is perpendicular to the plane containing C and D.
C and D. Yeah.
That means
It should be 90.
this is C bar.
90.
This
Now
is
I understood. Sir.
So it should be 90, no?
Yes, sir. It should be 90.
Yeah. That's important. So that is why if you want a unit vector, it should be like this. Now, next very important one, and this one is most important question. If A bar is any vector, please do that. If A bar is any vector, what we need is A bar cross I bar whole square plus A bar cross J bar whole square plus A bar cross K bar whole square is equal to mod A bar square 0, 3 mod A bar square, 2 mod A bar square. Now let me understand whether you followed the explanation of Lagrange's identity or not. Now, Kaushik will be telling me Lagrange's identity, and I'll help you out even writing LHS here. LHS of Lagrange's identity is A bar cross B bar whole square. Kaushik. Just now I derived it and Pranit also read it.
Sir, mod.
Pranit also read it.
Yes, sir. Mod A bar or mod A bar whole square into mod B bar minus mod A bar dot B bar whole square.
Correct, no?
Yes, sir.
Correct, sir.
Now, do you apply the same for the first term there?
Yes, sir.
Come on, tell me. For this one, in place of A bar is there. In place of B bar, I bar is there. Come on, tell me that. A bar
square, I bar square.
Very good.
By
minus.
Okay. A bar square, J bar square.
No. First of all, you split this, and after
Okay, this one. A bar dot I bar whole square plus A bar square, J bar square minus A bar dot J bar whole square plus A bar square, K bar square minus A bar dot K bar whole square.
Now, what is I bar square? 1. It is a unit vector. J bar square, it is also 1. K bar square, it is also 1. This is A bar square. This is another A bar square. This is another A bar square. Becomes 3 A bars. Are you there, please? Both of you.
Sir.
Now, I bar square 1, J bar square 1, K bar square 1, that becomes 3A bar square. Now, what is that remaining? A dot I whole square plus A dot J whole square plus A dot K whole square. Correct or not? Now, Kaushik, it is given that A bar is any vector. A bar is any vector. It is already given. A bar is equal to, for example, if I take it as xi plus yj plus zk. Come on, tell me what should be A dot I now?
Sir, A dot X.
X. Very good. A bar is equal to XYZ if you take. What is A dot I you said?
X, sir.
X whole square, X square. What is A dot J whole square? Y square. What is A dot K whole square?
Sir,
What is
Z.
A dot K whole square? Z square.
That's the
Now, if you add these two, add these three, X square plus Y square plus Z square. X square plus Y square plus Z square is nothing but A bar square. Correct or not?
yes, sir.
So what should it be then? 3A bar square minus A bar square.
A bar square. Yes, sir.
So your answer is 2A bar square. That's it. Model is important, please. This model question is important. He's doing something other than this, I think. Kaushik is doing something other than this, according to that keyboard sound.
My mail, sir. I'm opening that mail, sir.
Okay.
Okay, sir.
So this Lagrange's identity, please remember that.
Okay, sir.
Now, do you answer this example 35 directly? Just now I discussed the Lagrange's identity. This question is based on Lagrange's identity only. Any one of you, please.
A into B whole square. A dot B whole square is equal to.
Write that formula, then you will understand.
Okay, sir. All right. I'm right.
Lagrange's identity, please write and rearrange. You will get the answer. Kaushik,
Sir.
just write the Lagrange's identity and rearrange it to get the answer for that one. Yes, please.
Sir.
Sir, written, sir.
Sir,
What is the
A
answer
square,
then?
sir, A square, B square.
That's it.
Sir,
That's it, please.
So in bracket
we
we'll
come,
get the
sir, we'll get
sin
A.
square theta plus cos square theta.
No.
That equals to 1. So we'll get A square plus B square. A square B square.
Sir, A dot A into B dot B into sine square theta plus cos square theta, sir, which is equal
So you are
to.
simplifying that, Pranit. I understood what you're doing,
Yes.
but what I asked you now, just I asked you to write the Lagrange's identity. What we did now is
Sir, mod A mod B sine theta plus mod A mod B cos theta whole square.
to sine theta. Just tell me this Lagrange identity. Just now we did it. A cross B whole square is equal to A bar square B bar square minus A bar dot B bar whole square. Correct or not?
Yes,
We
sir.
did it now. Now bring this to other side. That's all.
Okay, sir.
A cross B whole square plus A dot B whole square is equal to A bar square B bar square. That's all.
Sir, but using both the ways, it's only taking 2 steps, sir. So
Okay.
I tried the other way.
It's okay. Then it's okay. You got the answer?
Yes, sir. Got the answer.
Very good. Okay, so if you see this, the answer is A bar square B bar square option B. And that's why he did it like that only. Okay, as you are saying sin theta, no, like that only it is. Now, very important one, what I said, you get frequently this question is example 36.
Okay.
And how do we proceed? How do we proceed to get a vector which is perpendicular to two given vectors?
Box of like data of A and B.
This is one vector, this is another vector. How do you get a unit vector perpendicular to both of these vectors?
We'll find it.
Just now I explained
A
it.
cross B.
A
A
cross B.
That's
That's it.
Then
Want to
substitute
make it a
in
unit vector?
sir. Then substitute in cos theta formula. A cross B by mod A into mod B.
No, you need not have to because cross product, you know, it is determinant, no? Determinant.
Okay. Okay.
Determinant IJK.
Mhm.
Come on, tell me 6 to 3. And 3 minus
3 minus 6 minus 2.
minus 2. Whole divided
Equal
by
to
modulus of this
minus 4
4 plus
divided
18.
by
It
14,
is
sir.
14, correct.
9
9 plus 12.
plus 12. 21. Minus 36.
Minus 6.
Minus 6. Minus 42.
That's it. This is the unit vector.
Writing it into simplest form. Taking 7 common.
That's it.
2i plus 3j minus 6k.
That's it, yes. Next, sign of the angle between the vectors. Sign of the angle between the vectors. How do we write that? A bar cross B bar is equal to mod A bar mod B bar sine theta.
Yes, sir.
Okay, if you want
Okay,
sine theta, no, then simply you have to find
mod A cross B by
mod
mod A into mod B.
that.
Like, the past formula should be applied to this formula.
That's all.
This problem, sir.
Yes. Okay.
Got it, yeah.
And next part is the geometrical applications of cross product. What is this? Is also very important, please. Geometry.
38th one, sir.
Not 38 one. 38 one. You tell me. I did not see that. Yes, more.
The vector C A is equal to xi plus yj plus zk. B is equal to j. Such that A, comma C, comma B form a right-handed system. Then C is.
C is.
He gave A and B values. We need to find the C.
Yes.
So A
right-handed
C is
system.
equal to B into A or A into B.
C bar is equal to A cross. That's it.
A cross B. That's it.
If you find out, you'll get it.
Which is equal to xi plus yj plus zk into j.
Means you tell me first of all cross product. First row is IJK.
IJK, sir.
And the second row XYZ.
XY.
Third row B bar.
No, it's not XY. XJ. Yeah.
A bar.
Sir, B is given as J, na, sir.
B is given as J. That is the reason why 0, 1, 0.
Yeah, 0, 1, 0. Third row is XY.
You can write anyways, no problem.
Okay, sir.
But I wrote it as C bar is equal to A cross B, no?
Okay, sir.
First you have to write A bar and then B bar. I into minus Z, so minus IZ. And it is J0, K into X.
Minus X.
That's it. This is the answer.
Got it, sir.
Read out first option.
Yes, sir. First option.
Similarly, we'll have the geometrical applications of cross product. This is the last part of.
Sir, it's fourth option, sir, not the first.
Minus Jedi.
Minus IJ. It should be minus kx, sir. It's minus kx. IJ is positive, na, sir.
You're right. So fourth option, no?
First option, sir. Now, after interchanging the signs, it's first option.
I minus kx. And here minus Zi plus.
Just interchange the signs, sir.
Oh, right. They form a right-handed systems. Okay, you have to
Right-handed system,
the same order.
A should be negative and A should be positive and B should be negative.
You're right. I have not noticed this order here. This order is A bar, C bar, B bar.
B bar, sir. Yes, sir.
Then you have to follow that order. That is
Following the order, you will get
C bar is B cross A, not A cross A.
yes, sir.
It is to be written like this. You're right. That is why you will get a change of minus here. Change of minus. And next part is geometrical applications of cross product. Geometrical applications of cross product. We will see that in the next session.
Okay, sir.
Okay.
Okay.